So this is 1-6 homework. We are in the textbook on page 45. We're doing 3 through 10 and 12 through 16. Looking at absolute value. So number 3, x equals -40 and y is 35. Find each expression. So we're just plugging into these things, solving, understanding what absolute value does. So it's x minus y inside the absolute value. So just looking at this before we worry about the numbers, we're going to go ahead and do the subtraction inside, and whatever we get, absolute value makes it positive. That's the basics of it. Absolute value is asking you how far a number is from 0 expressed as a distance. The distance is always a positive number. So basically what it does is make this positive. But you don't go in here and make this a plus, common misconception. You solve the problem, whatever's inside. Last thing you do is make it positive. If it's already positive, you leave it. So I'm going to go ahead and plug in x is -40 minus y is 35. Finish that off, that's -75, still inside absolute value. Now the last thing you do, once you just have a single number inside, you take the absolute value, which just makes it positive. So in this case, it's going to be a positive 75. So for letter B, now we have y minus x inside those parentheses. So y is 35 minus -40. Well, minus a negative goes plus plus. So this is 70, and the absolute value of 70 is, not 70, 75. And the absolute value of 75 is 75. So if it's a positive number, how far is it from 0? 75. If it's a negative number, how far is it from 0? 75. So one other common misconception is when you see the absolute value, you change the sign and make it negative or positive. That's not true. It just makes it positive because it's asking you for the distance from 0. So anytime you have an absolute value question, the answer is going to be positive. C. Now we're going to add x plus y. So it's -40 plus 35. When you add those together, you're going to get -5. And then the absolute value of -5 is +5. And I'm going to slide this over here, squeeze it in. Absolute value of x plus the absolute value of y. So now the addition is not included inside of the absolute value. So we're going to actually take the absolute value of each one first and then do the addition. Those are kind of like parentheses. You got to do the inside first. So it's the absolute value of -40 plus the absolute value of 35. So that makes them positive. It's 40 plus 35, and it's 75 when you add it together. Okay, number 4, adding fractions. What I need to notice is this is a negative. You can put the negative here, you can put it up top, you can put it out front. If there's just one negative, the whole fraction's negative. So it's a positive 3/5 plus a negative 3/5. That's what we're actually doing here. I'm going to go ahead and just put it out front because I know it's the same thing. So whether it's down here on the 5 or up here on the 3 or sitting out in front, kind of like I have it here, it means the same thing. So that's important. Now, absolute value of both of these makes them positive. If they're already positive, they stay positive. So really, this is just 3/5 plus 3/5. You can run that through your calculator, but I do kind of want to remember fractions. I don't want to get rid of them entirely. You have a common denominator, so that means you just add the tops, and so it's 6/5 as a final answer. If you converted that to 1 and 1/5 because you remember doing that, that's fine too. Let's just make sure we can do this in the calculator if need be. So using your scientific, ABC button is right here. So it would be 3 ABC button 5 for 3/5 plus 3 ABC button 5 for 3/5. And together it's going to give you 1 and 1/5. Now it converts it directly to that. Your graphing calculators are going to just give it to you as 6/5. So we just need to be able to go between the two. 6/5 is equal to 1 and 1/5, but in algebra, we actually don't like this answer as much. It's harder to work with. We have to constantly convert it in and out. Leaving things as an improper fraction in algebra is preferred. I know that goes against every rule that you learned previously, but from now on, improper fractions are good to go, good answers. Okay, number 5, absolute value, -1 minus -2. Again, common misconception is you go in and you just make everything positive because of the absolute value. That's not true. You answer the question on the inside, And the very last thing you do is you make it positive if it's negative. If it's already positive, then it's going to stay positive. So first of all, this goes plus plus. So it's -1 plus 2. That's +1. Now you take the absolute value, which doesn't change a positive number. It stays positive. Number 6. When you look at this, the only reason I assigned this question is because I want you to see this and understand it's the same thing. Some calculators, including your graphing calculators, when you try and do absolute value, it's not going to write it with these bars. It's going to write it like this. Okay, so this is the absolute value of 2, which we can rewrite with the bars. Okay, that says the same thing. Absolute value of 2 minus absolute value of -20. So that's important. That says the same thing as this. Now, since this subtraction is not on the inside, we're going to go ahead and complete the absolute value first. Those are like parentheses. They're grouping symbols. Comes first in your order of operations. The minus will be the last thing we do. So this is positive, minus, and then that makes this -20 positive. So it's going to be 2 minus 20, and that's -18. Okay, number 7. It's the absolute value of x over the absolute value of -x. So you're plugging in this decimal. I will write it out, but just looking at this, I already know the answer. You're plugging in the same number on the top and the bottom, regardless of what this is. You're plugging in for x in both spots. So it's the same number. On the bottom, it's the negative version. On the top, it's the positive version. But if you end up taking the absolute value of them, the negative version becomes positive. So it's going to be the same number over itself, which is 1. So I already know this answer is 1, but let me write it out. So the absolute value of x, 4.8673, over the absolute value of -x, so -4.8673. If I convert that, not convert it, but run the absolute value, I have 4.8673, the positive version. I get the same thing on the bottom. Absolute value gets rid of the negative, and anything divided by itself is 1. Okay, number 8, they want us to graph this. So I'm going to make a quick sketch. It doesn't tell you what your graph has to be set up as. So I'm going to count by 5s and just do those. That would be negative. And let's see, thinking about numbers I'm plugging in. At 0, I'd be adding 5, so I have to go up to 5. At 5, I'd be adding 5. I'm going to have to go up to 10. And at 10, I'm going to be adding 5 and have to go up to 15. So just thinking about those numbers, I'm going to make sure my graph goes high enough. So analyzing the situation before I make the graph and make the graph fit the situation. So I'm going to start with 0. What you can do is you can make a quick little, it's called a t-chart, and plug in values for x. I'm going to plug in these values here, get the y values, and then you just put it on the graph. So I'm going to start with 0. And these don't have to go in order. You can put your x's, you can go from a 0 to a negative to a positive. You don't have to have these in numerical order. So when I plug in 0, I'm not going to actually write it down. 0 plus 5 is 5, and the absolute value is +5. So 0, 5 is right here on the graph. How about +5? 5 plus 5 is 10. Absolute value of 10 stays 10. So 5 is going to go up to 10. If I plug in 10, I get 15. Now let's try the negatives. So what about -5? So when x is -5, what is the y value? So -5 plus 5 is 0, and the absolute value is going to keep it 0. So there's that. What about -10 now? So -10 plus 5 gives me -5, but I have to take the absolute value of -5, which is +5. So at -10, I'm going back up to +5. And you'll see this line is going to make that V. And it will go on forever, even though we're not going to go graph all those numbers. There's clearly numbers after 10, so you want to put that arrow. There's clearly numbers less than -10, so you want to put that arrow. And there's numbers between these, right? There's a -1, there's a -2. This has to be connected. So there's your graph. These absolute values are always going to make that V shape. All right, that's number 8. Let's slide over here and do number 9. So we want to find a value for t in which this and this are not equal. So let's analyze the situation. First thing I always do is like plug in a 0. So if I plug in 0 here and 0 here, I'm going to get 0 on both spots. So that's not a good example. When are they not equal? Well, plug in a positive number. If I just plug in positive 1, I get 3. Positive 1, I get negative 3, but the absolute value makes it positive. So I got the same answer. So what do you think is going to most often mess up an absolute value equality? A negative number. Okay, so let's plug in negative 2. So let's say t equals negative 2. I just picked 2 randomly, but a negative number. So if I plug that in for 3t, it's 3 times negative 2, and the answer is negative 6. Now, I already know that that's going to be different than this because no matter what, this answer will be positive because it has the absolute value there. So I already know this is good, but let's show the work. So inside the absolute value, it's negative 3t. So inside the absolute value, it's negative 3 times negative 2. Now, when I multiply that, I'm going to get a positive 6, and the absolute value is going to keep it positive 6. Okay, so these are not equal. So the values here that are going to make this happen are any negative number. Okay, number 10. We want to test whether these are equivalent. So again, let's go to our negatives, because if you plug in 1, 1 plus 4, that's 5. Plug in 1, stays positive. 1 plus 4 is 5. They're both 5. 0 plus 4 is 4. 0 plus 4 is 4. So you got to test your negative numbers. So let's test x equals negative 2 again, just to be consistent. Why not? So when I plug that in here, negative 2 plus 4, negative 2 plus 4 is positive 2. Absolute value is 2. What about over here? So it's good if I write this out. So let's make sure we write these out. So then directly underneath, absolute value of negative 2. Well, I got to do that first. That's a grouping symbol. That's like parentheses. So that becomes a positive 2 plus the 4, and my answer is 6. And so my answer is no, these are not equivalent. If you can find an example, called a counterexample, that proves it to be untrue, that means they're not equivalent. All right, number 12. We're going to find all the values that make this true. So we have the absolute value of x equal to 15. So what values could we plug in for x to get this answer? So obviously positive 15. But if I plug in a negative 15 and take the absolute value, it does also become positive. So I need to include that in my answer set. 2 possible answers here, 15, negative 15. How about 13? I got w minus 5 equals 0. So the only way that this is going to give me a 0 is if I get 0 on the inside, right? I can't get a positive 1 and it equals 0. I can't get a negative 1 and get it to be 0. So I have to get a 0. What's the only way to create a 0 here? It's when w equals 5. So there's a lesson to be learned here. When the absolute value equals a positive number, there's 2 possible answers. When the absolute value equals 0, there's only 1 possible answer. Well, number 14 takes care of the other scenario. How can I take the absolute value of a number and get a negative? You can't. It's a trick question. So there's no answer here. There's nothing I can plug in for z to create a negative. So when an absolute value equals a positive, there's 2 answers, the positive and the negative version. When it equals 0, there's only 1 answer because there's only 1 way to get a 0. And when it equals a negative, there is no answer, there's no solution at all. Now 15 really makes you think, kind of like a challenge question. Don't expect everybody to get that one on the first try. So let's take a look at it. So we're saying that these are going to be equal to each other. But this one has an operation. So how's that even possible? Like if this was 2 and 2 minus 1 is 1, that changes the value. It doesn't make sense. The only way that this is going to equal each other is if we somehow minus 1 and we end up with the negative version of this. So we have, let's say we have the positive version. Let's just call it 10 for a second. And we're minusing something. We'd have to get negative 10 on this side. And the absolute value would make it positive. And then, oh, we got 10 equals 10 now. So obviously it's not 10 because 10 minus 1 is at negative 10. So what's the number when you minus 1 that you get the opposite of it? So 1 minus 1 is 0. Doesn't get me the negative. What if it's 0? 0 on this side, 0 minus 1, negative 1. No good. So we actually have to start thinking smaller. So what number minus 1 gives you its opposite? And I'm just going to go ahead and give you the answer, and hopefully you can see it. It's 1/2. So you would take the absolute value, it's just 1/2. 1/2 minus 1 is negative 1/2, and the absolute value would make it positive. So just that one was only assigned to one, challenge you a little bit, but then after you see the answer, hopefully you kind of have that aha moment and you're like, oh, I get it, that makes sense. So I didn't expect you to look at it and necessarily understand it. I'm hoping you're watching this video because you circled this one and you said, I have no idea how to do that. And now that you've seen it, not that you'd necessarily be able to answer this again if you see it again exactly how it is, but you just understand where the 1/2 comes from. It makes sense. I plugged in a number that when I subtracted this, whatever it is, gets me the opposite, the negative version, and the absolute value then makes them equal. All right, last one is number 16. We got to flip this over. Got a lot of parts here on 16. So we're going to use the graph at the right to answer these questions. So part A, first thing we got to do is fill in this chart. And they're giving me the x values of 1, 2, 3, 4, and 5. And so when x is 1, you're going to go to your x-axis here, find 1, and just put the value in. So that's 2. When x is 2, it's 3. When x is 3, it's 4. And at 4, it starts coming back down. Now it's at 3, and at 5, it's at 2. All right, so that's part A. Just fill in that chart. Now, letter B. What's the value of the expression? When they say that, that's the y. What is the y value when x equals 4? So if you get confused, look at what they give you. They said x equals 4. They're giving you x, so they're obviously asking for y. So when x equals 4, go to where x equals 4. What's the value of the expression? It's 3. And you could have got that also from the chart. So let's say they didn't give you the graph and they gave you this chart. They could ask the same question. What's the value of the expression? What's the y value when x equals 4? So you just go to where x equals 4, and it's 3. So whether it's from the graph and you see 3, or the chart and you see 3, or table, okay, we know that the answer here is 3. Letter C. What's the x value? So now they're asking for the x value. So we don't know the x value. They're going to give you the y value. So what is the x value when the value of the expression is 4? When they say value of the expression, that's the y value. So when y is 4, what is the x value? So find where y is 4, x value is 3. So those questions are just a little confusing. What are they asking for, x or y? So the way I like to do it is just look specifically at the information that's given to you. Forget what they're asking, what's given to you. Here they said x equals 4. So they told you x, you're looking for y. Here they said the expression is 4. The value of the expression is 4. And they're asking you to find x. What is x? That means they gave you y, go find x. All right, and then last one, letter D. Which one of these is the graph? So easiest way to do this is look at the numbers that you've already got, okay? Plug them in and see if they work for this. I'm going to start with 0. If I plug 0 into the correct equation, I have to get 1. That's what my graph tells me. So if I plug in 0 here, 0 minus 2, I'm not getting a 1 here. That's out already. I've already eliminated it. What about this one? 0 minus 3, well, that's negative 3, but absolute value makes it positive, so it's positive 3 plus 4 is 7. So when I plug in 0, I'm supposed to get 1. I plugged in 0, and I got 7. No good. So I've already eliminated these two. It's one of these. I'm going to skip letter C because that looks complicated. Why don't I just go look at letter D? So I plug in 0. 0 plus 1 is 1. So it works. I'm supposed to get 1. I got 1. So I'm already thinking, oh, sweet, this is the answer. But you got to be careful. What if they both give you the same answer for 0? What if, right? So let's check a different value and see what happens. So what if I plug in x equals 1? I should get 2. Plug in 1, I get 2. My confidence now is going up that this is the correct answer. Plug in 2, I should get 3. Plug in 3, I should get 4 because I'm just adding 1. But what happens when I get out here? If I plug in 4, I should get 5. I'm not getting 5, I'm getting 3. What if I plug in 5? 5 plus 1 is 6. So I should be having a dot up at 6, but it's at 2. All of a sudden I realize this is not the answer. So by process of elimination, I know that the correct answer is C. But before I went ahead and did that, if this was a test that I was taking and this mattered, what I would do is I would go ahead and actually plug those in. So if I plugged in, say 0, 0 minus 3 is negative 3, becomes a positive 3. You multiply that times this, 3 times negative 1, now it's negative 3, added to 4 is 1. So it's complicated, but it worked. And I would probably double check myself a couple times, but if you keep plugging those numbers in for letter C, you're going to find out that that's actually the correct equation. So moral of the story, look at the graph, look at the chart, and pick an x value and plug it in. If it doesn't work, you've already eliminated the answer. If it does work, it doesn't necessarily mean you've got the right answer. Okay, you got to try a couple values and see if it works for everything, because it's possible this x plus 1 would be the line that keeps going up. So yeah, it's part of this, but it's not going back down. The only way you see one of these V-shaped graphs is when there's an absolute value. So we actually could have eliminated this right away if we knew what the equation of a line and an absolute value function looks like. And we're starting to learn that. This is the equation of a straight line. It's never going to bend. It's never going to have an angle. Absolute value functions have that V shape. They're going to come to a point. So we know this is never going to come to a point, so that's not going to be the graph. And these, while they are also going to come to a point, just don't fit this particular graph.